Hi friends, welcome back. So today we will see a case study on loss given default, right? So that is basically comes under a supervised learning problem. So again, let's start. What we have the context is a CNB bank deals in all kinds of car loans. Customer first apply for loan after the company validate the customer eligibility for loan, right? In case the borrower doesn't pay back the loan, the losses are to be incurred by the bank. So the LGD or the loss given default stand for the loss given default. So it means when a customer at a bank defaults on his loan, right? So how much money does the bank lose? Okay, so the customer might have paid some amount back or no amount at all, right? So the bank wants to know if the amount the bank losses can be predicted for new customers who apply for a loan from the past data of the all defaulters and their pending amount, right? So this was the context. Now we have a problem statement, that is the bank wants to automate the loss estimation based on customer detail provided while applying for loan. These details are ages, years, experience, number of cars, gender, marital status. To automate this process, they have given a problem to identify the loss estimation given that the customers is a defaulter. Okay, so those are eligible for loan amount, so that they get to know what features are leading to defaults up to which amount. Here are the detail about the data set. So this is the data, right? We have variable description, AC, no account number, the account of customer user as a identifier, age is there, years of experience, number of cars, gender, married, loss in thousands. So let's start with doing that. So first let's import our all necessary library, pandas, pd, right? Numpy as numpy, matplotlib for visualization, again seaborn is also for visualization, right? Then we are importing stats models formula, right, for all the statistical APIs. SciPy and stats for the statistical evaluation as well. Then math for a log function inside the library. Now this is used to get the plot in line, right, in the same page. Okay, so that is collection import counter, right? So let's start. We have a CSV, that is LGD. Okay, I'll also providing the same CSV in the description. You will find a link so you can get the CSV from there. Now first we are doing PDA, EDA, right? So that is nothing but exploratory data analysis. So we have df.info function. So this tells all the number of rows, column and their detail, right? So here you can see that we are calling this function. It is telling us all the attribute with their respective values, right? And here we have total 7 columns, and the rows that we have are this one, 15,290. Okay, now we are getting the head of the data frame, so this will return top 5 values. Okay, so df.head, you can see that this will our data frame look like. Now we are plotting the histogram. So what we are getting is we are having SNS, that is cbone.displot. We are getting that losses in thousands, right? So this attribute we will get the our histogram, and KD is also false. Bins we are needing 50. So here you can see that in all those 50 bins it will return the plot histogram, right? Next thing is this probably means we should take the log to normalize the data, right? Because after that obviously we will have to normalize it. So what we will do is first again we are getting the loss in thousand. Okay, so the same that we used to get here. All right, and then we are telling that okay, KD is false and bins equals to 50. So here also you will get the same thing, because again we are trying to do the same, but here map function is used to apply any function on each element of series list, right? Now distribution model will look like this. So if we get for different attribute, that is on age, so for age it will be like this according to the data that we have. Years of experience also, this is the this plot. So here you can see that the years of experience, right? Next thing is the box plot that we are getting on married, and y is our loss in thousands. So data is our df and u equals to on the basis of gender. So here you can see that married and losses in thousands. So if married couple is there, so the losses in thousand, and if it is a single couple, so the losses in thousand there. So you can see the loss in single for male gender, that is greater than, right, that is greater. So next thing we are getting the correlation. So we see a high correlation between age and years of experience, right? So which is obvious as with the age your experience increases. So here you will get the correlation for all the column, account number, age, years of experience. So here you will get the matrix like format, right? So for years of experience with age you will get this correlation. Okay, hope you remember that, the correlation matrix. Next thing is that the first, let's build a simple model with all variable, and as is we will have to convert the string variable to dummy variables, right? So dummy variable will be our pd dot get dummies. So this will be our gender, and drop first equals to true. So similarly for married, so we will do the same thing again. Then we are getting the head for this variable too. Now what we are doing is we are merging the above these two data frame with the original data frame, right? So in this one we get only gender, then we will get the married in v2, and we are concatenating both of them on the basis of xs1. So this will return the final data set that you can also verify it, right? So how will it look like? So here we will get all the genders, and for the married couple also, so gender we have male female male female, right? But here you can see that married single, married married single. So for all these attribute we are covering everything. Now we no longer need married and gender column, we will use their dummies instead. So what we will do is we will drop the married column, and but we are getting in that in new data frame, right? Gender and married. So here you can see gender and married are dropped from here, and the rest is our df new data frame. Next thing what we are doing is deciding our regressor and predictor variable, right? So here what it will do, here we are getting x and y. X is our data frame of age column, number of vehicles, male and single, right? Male, single, age, and number of vehicles. Then for y we are getting losses in thousands. Okay, so now let's import our train test split from sklearn model, and we are getting x train, y train, x test, y test, right? So this will call the function that is train test split. Now we are getting the value of x for x train, then value of y for x test, right? Now what we are getting is test size, that is training size is 30%. Okay, and next thing, the random state, that is our 1. So finally here we are importing one more linear regression function. So this is what we call the function here in this lm, so that is linear regression. Now we are trying to lm dot fit this x train and y train, right? So fitting the model, we are calling this linear regression here, which will print the intercept of this function, and we are also getting the coefficient, or we can say see the betas, right? So finally we are importing a matrix here. Okay, so now at the last we try to predict the final prediction, right? So prediction will be our predict dot x test. So the x test we have will be our prediction variable. Now printing the matrix dot mean absolute error, so that is MAE, right? And on the basis of y test and prediction. So you will get that from sklearn dot matrix import r2 dot score. So r2 dot score, inside you will provide y test and prediction, and finally you will get this values. So you can see that this will be your final score, right? So that is the MEA. So next thing what we are getting is we are having the linear regression model in the regression model, and again we are doing regression model dot fit our x train and y train, right? So here you can see that it will give us copy x, that is true, fit intercept is also true, and jobs, that is none, and normal I is equals to false. But finally if you try to get the model score, so here you will call regression model dot score x train and y train. So these will be our 0.30, or you can say 30%. So what you can say that according to a problem statement, right, here again I'm speaking it, that is the bank wants to automate the loss estimation based on customer detail provided while applying a loan, right? So the customer detail we had is the data frame that I was talking about. These detail are age, all right, all these attributes are there in the data frame. Now to automate the process, they have given a problem to identify the loss estimation given that the customer is a defaulter. Okay, so those are eligible for loan amount, so that they get to know what features are leading to default up to which amount. So here are the details. So here all those customer which are eligible for the loan amount or not. So here we will get the final that we have 0.30, or we can say 30% of the customers are there. So okay, so this was all about this LGD. All right, I'll come up with some few interesting topic of supervised learning, and this will go, we will keep moving toward our AI ML journey. Thanks.